In May of 2017, tourists who were resting after climbing one of the peaks in northern France witnessed a strange phenomenon. They were watching the starry sky over the English Channel, but instead of stars, they saw this. A giant red jellyfish that was too high to be just a firework and too far from the North Pole to be the Northern Lights. But what was it then? In this video, you'll find out where on Earth does lightning strike 40 times per minute, what wildest atmospheric phenomena can be seen with the naked eye, and how to find a giant red jellyfish in the sky. First, let's consider the most obvious option. The red jellyfish captured by eyewitnesses in the sky could just be the distorted northern lights. It can only be seen at the poles, but similar atmospheric phenomena are also found farther south. For example, fire rainbows. Despite their name, they have nothing to do with fire or rainbows. This extremely rare atmospheric phenomenon occurs at an altitude of 4 to 20 kilometers. A fire rainbow appears when sunlight passes through cirrus clouds at an angle of 58 degrees above the horizon. Also, the hexagonal ice crystals that make up cirrus clouds must be shaped like thick plates facing parallel to the ground. Then, and only then, the sun's rays passing through them color the clouds in rainbow hues. Interestingly, when these crystals form low above the ground, we can see such pillars of light. The beams of streetlights and the lights coming from houses are refracted through these crystals, and we observe an unusual glow. However, this atmospheric phenomenon appears only at temperatures from -10 to -40 degrees Celsius. So, if you want to hunt for rare pictures, try not to freeze to death. But neither the fire rainbows nor the pillars of light look anything like a giant red jellyfish. But what could glow so bright in the night sky then? If the red light doesn't look like refracted rays, it could probably be lightning. To find out if lightning can possibly be like that, we need to go to Venezuela and visit the Catatumbo River Valley. That place has lightning storms nearly 260 days per year, and lightning strikes 40 times per minute, which is more often than anywhere else on Earth. But nobody really knows why this happens. Some researchers suggest that in this zone there are cold air currents from the mountains and warm air currents from the local swamps. Other scientists believe that storms and lightning provoke methane accumulation in the atmosphere. And in 2016, a team from the University of Zulia in Venezuela put forward the third hypothesis. They think that other abnormally active weather zones of our planet affect the appearance of the Catatumbo lightning. For example, the Intertropical Convergence Zone, where most tropical storms are formed. But as incredible as the lightning bolts are over the Catatumbo River Valley, none of them look like a giant red jellyfish. But what if we're just looking at the wrong lightning? The so-called dirty thunderstorm is a rare phenomenon that can be observed during volcanic eruptions. Volcanic ash particles collide and build up a static electric charge, resulting in unusual lightning events. But be careful. To photograph them, you'll have to get too close to the rivers of hot magma. And it would be absolutely useless, by the way. Volcanic lightning doesn't look like red jellyfish either. So let's look at this from another angle then. What if it's not the lightning itself, but an oddly shaped cloud illuminated by a flash? For example, such a lenticular cloud. They're usually formed near mountain ranges at an altitude of 2 to 15 kilometers. Or maybe it was one of those unusual clouds. Wait, is that a rubber duck in the sky? It looks like our investigation has gone the wrong way. Let's get back to lightning, but this time, let's consider the most unusual of them. In fact, during a thunderstorm, the electric discharge creates not only the lightning familiar to us. If we rise above the clouds, we can see, for example, blue jets. They appear as if mirroring lightning, going from the tops of active thunderclouds up towards space. This rare phenomenon occurs in the stratosphere. A negatively charged layer emerges above the positively charged cloud, and the resulting discharge propagates upward over the storm. The discharge colors the nitrogen in the atmosphere in a bluish-purple hue, hence the name blue jet. But what does this have to do with the red jellyfish? Let me explain. In 2019, pilot Chris Holmes was in the sky over the Gulf of Mexico during a thunderstorm, and at an altitude of 10.5 kilometers, he managed to capture this. A giant blue jet goes up and turns red. Such jets can even reach the ionosphere and rise to an altitude of up to 80 kilometers. That's why they partially change color. Nitrogen glows in different colors due to pressure differences in different atmospheric layers. To get such unique shots, you'd have to get on a plane and rise into the sky in a thunderstorm. But at least we're one step closer to a solution. What if we rise even higher above the thunderstorm? If the top of the giant jet can glow red, the discharges in the upper atmosphere will also be red. Now, watch closely. Did you notice a giant flare? That's a tremendous red sprite, a discharge formed at an altitude of 80 to 100 kilometers. Such discharges can even be seen from space. For example, in this photo taken from the ISS. Red sprites exist for only fractions of a second and come in three types: column sprites, carrot sprites with long tendrils, and jellyfish sprites. Such a sprite was first photographed only in 2015, and their nature is still a mystery to scientists. Sprites are considered to occur over hurricanes and thunderstorms when a discharge of accumulated electricity hits plasma in the upper atmosphere. At the same time, when shooting a sprite with a camera operating at 10,000 frames per second, researchers noticed something strange. It turned out that the flash consisted of clusters of small balls of ionized gas with a diameter of 10 to 100 meters. At the same time, these balls moved down at a speed equal to 10% of the speed of light. And a few milliseconds later, they meet similar balls that move up. And all of this happens in fractions of a second. Along with sprites, even rare atmospheric phenomena may appear above the storm. For example, elves, trolls, and ghosts. Elves are concentric rings of emissions caused by an electromagnetic pulse over a thunderstorm. Elves occur in the upper atmosphere and can reach up to 400 kilometers in diameter. They disappear 5 times faster than sprites, so you can't see an elf with the naked eye. Trolls look like a collection of red spots with reddish tail-shaped streamers directed upwards like blue jets. They appear after powerful sprites, just like the ghost, barely noticeable green glow of oxygen. But of all these strangely named phenomena, only a sprite can be captured with a phone's camera. And it looks like the eyewitnesses managed to do it. But there's one more thing that still remains a mystery. To take a picture of a sprite, you need to rise higher above the thunderstorm, because from the ground, they don't usually look that impressive. But if that's the case, then what the hell did the eyewitnesses capture on video?